Today we're going to talk about transformations, transformation rules. We'll spend 3 days on this. We'll spend today, tomorrow, and Wednesday going over it. Transformations are all about moving stuff. So moving a graph left, moving a graph right, stretching it, compressing it, anything else you can think of, flipping it upside down, whatever. Doing pretty much anything and everything to different graphs. When we talk about the transformations, we're usually talking about using this equation right here. You already have that written on your paper, don't have to write it down. We're going to talk about what each little thing does here. Here we'll get to the A, with the K in a moment. The first thing is if A is negative, it says it right there, then the graph becomes reflected across the x-axis. Got two examples there, negative x squared, and then the negative absolute value of x. So if our parent function quadratic, y equals x squared, looks like this, that's y equals x squared. Then my negative, what's that one going to look like? Negative x squared. The side. Did I get one speak? No. Get one here. Still yours. Questions about what's happening there with the flipping or anything like that? Anytime there's a negative, it just flips. That's all you gotta know. Flips, 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 flips. Alright, if we have an H, and it's moving, and it's a minus sign, we're going to move to the right. So anytime there's a minus, minus 5, minus 4, minus 3, we're going to shift to the right. Even though it's a minus sign, we're still going to the right. So what can we deduce if it's a plus symbol? That goes to the left. Alright, so far, here's what we've done. We've flipped it over the x-axis. What's here, and now it's here. Next thing we did was we moved to the right. So if I took this parent function right here, I'm going to move 5 units to the right. So this little vertex right here is now going to be 5 units over, like that. Same idea, if it's a plus symbol, it's kind of opposite of what we think. It's going to move to the left. So using my same example here, since I have the parent function, it would go 5 units to the left. Questions? Okay. Now we're talking about K. We're talking about this value right here. If it's a plus symbol, what do we think is going to happen? Left? Okay, but that was on the inside. We already covered that. Now we're talking about if it's on the outside of the parentheses. We see the difference between here and here. This one's on the outside of the parentheses. This one's on the inside. We just add 5 to something. What do we think is going to happen? Get more or get less? More. So we're going to shift vertically. So we're going to shift, shift up. And then if there's a minus sign on the outside, what do we think? Yeah, shift down. That's it. That's all you got to know today. Those 5 things. If it's a negative, flips upside down. If it's a plus sign on the inside of the parentheses, goes to the left. If there's a minus sign on the inside of the parentheses, goes to the right. If there's a plus on the outside of the parentheses, it goes up. And then if it's outside, it goes down. Questions? Is it easy? Yeah? All right, let's apply this a little bit. Number 1 says determine the parent function. So what is the parent function for number 1? Linear. Cool. So let's plot the parent function using 1 color. So if you don't have 2 colors, no worries. We'll just make this one dash, something like that. What does the linear parent function look like? You know what the equation is?
Yeah, y equals x.
All right, y equals x. Do we know how to graph y equals x?
Yeah.
Where do I start?
Origin.
The origin. And I just go up block over block?
Up 1 over 1.
Up 1 over 1.
Right.
Rise over 1. Slope. I'm going to make this one dashed. You don't have one color, or you don't have 2 colors, it's cool. Alright, x plus 5. I'm now graphing my original problem here. First it says determine the transformations. So if I have a plus sign on the outside, what's going to happen? Moves up. How many? 5. Just a plus symbol on the outside. For a linear, it's kind of weird because there's no parentheses, no other signs or symbols or anything like that. But we're just adding or subtracting. So it's going up 5. So how am I going to do this? How do I do it? I go up 5 from my origin. I'm just going to go up 1 over 1. This is the same thing as graphing y equals x plus 5. The y-intercept is 5, go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, over and over and over again. Pretty good. Sorry, I forgot arrows. My bad. Difficult, easy, challenging, piece of cake?
So-so.
So-so? Okay. Let's move on. I got it squared, so what does that tell me for the parent function?
It's quadratic.
It is quadratic, well done. Gotta learn our parent functions. Someone other than Xavier, what is the equation for quadratic? Y equals x squared, yeah. Now let's just go ahead and graph a rough sketch of what y equals x squared looks like. It starts off at 0. And if I were to plug one, no, it's a u, right? Do you remember that? So if I get my exact points, 1, 1, and -1, +1. If I put 2 into this equation, what's my y value going to be? If I put 2 in, 4, right? 1, 2, 3. Same thing on this side. So, not exact, but pretty close to what the shape looks like. Okay, transformations. If I got that -6 on the outside, it's not in parentheses, it's on the outside there. What does that tell me I'm going to do? Good, Harry, I'm going to go down 6. Down 6. So I'm taking each point that I just graphed, and I'm going to go down 6 y values. So instead of being at 0, now it's going to be at 0, -6. Instead of being at 1, 1, now it's going to be at 1, -5. Instead of being at 1, sorry, -1, 1, now it's going to be at -1, -5. Maybe 2 more points that we got on there. So being at 2, 5, now where is that?
2, -1.
2, -1, and -2, -1. How are we doing? Talk to me. Doing all right? Silence makes me think you got it. Okay. Number 3. X minus 4 cubed.
Cubic root.
Just cubic. Misconception on the quiz is that when we have this symbol, that's cube root. When we have 2 to the 3rd power, that's cubed. Okay. So what we have there is cubic. Cubic kind of is the weird one. Cubic's the one that kind of looks like this.
Yeah.
Alright, hopefully remember that now. So let's get some easy points. First one, 0, 0. Right, because 0 cubed is 0. What about 1 cubed?
3? No.
That would be 1.
1.
1 cubed. 1 times 1 times 1, not 1 times 3. Okay, what about 2 cubed?
6.
Ooh.
Oh, just kidding.
8. I got 1/2. What about -1 cubed? Yeah, it'd be down to -1, and then -2 cubed would be at -0. Okay, what's my -4 tell me? Bailey, you know? What does my -4 do?
Alright, so that means
It would be to the right. Well done. Goes to the right 4. If you want to actually write out right 4, that's fine. If you just want to do arrow 4, that's cool, whatever your heart desires. So what does that tell me for the transformations? What am I doing to each point? Moving each point to the right 4. That's a silly question, right? So I'm adding 4 to each x value. So that means 0, 0. Now it's at, I can count, 4, 0. I don't want you to get 1 point. The rest just kind of fall in line. All right, what's the parent function?
y equals.
Well done, yeah, cube root. So y equals the cube root of x. That one has our points at 0, 0, 1, 1, 1, -1, 8, 2, and -8, -2. Did we get that far?
Yes.
Sweet action. All right, how many units are we moving and which way and all that stuff? 1 unit to the right. Because the -1's on that inside of that root symbol, or parentheses, or however you want to think about it. So that means that I'm moving each of these points 1 to the right. Pretty much looks very similar. Just like that. It would be kind of the equivalent of everything down one. It kind of looks the same way. Down. Yeah, it would still be to the right technically, but I think it would look exactly the same either way. Shall we go to the back? Got 2 more of these graphs hammering it home here. Okay, number 5, what type of graph is that?
Absolute value.
It is absolutely absolute value. The equation is y equals the absolute value of x. What's that -3 tell us we're going to do? We're going to go down 3. If we're going to go to the right, it would be in the inside of those absolute value bars. So absolute value of 0 is 0. What does absolute value do? Keeps it positive. Right? So all my absolute values of 1 is 1, absolute value of 2 is 2, absolute value of 3 is 3. So that just kind of looks like the linear parent function there. What about my other side though?
Isn't it all negative? I mean, positive and negative.
Makes the B, right? So any negatives should turn to positive. So absolute value of -1 is 1. Absolute value of -2 is 2. so on and so on. So it mirrors itself. It's kind of symmetrical. All right, so going down 3, moving each of my y values. X values stay the same, but y go down 3. So I got a v still. It just moved down 3. All right, the last one of these. Hope we're all sitting down because this one's going to be crazy. Good thing we had a couple days off just to prepare ourselves just like this next one.
And then square root.
The parent function is just square root. None of our parent functions have any negatives. So just square root. The equation for square root, y equals
Square root of x.
square root of x. This time, the reason why I wanted you to sit down, because it's going to blow your mind, is that we have 2 transformations. We can list them in either order, doesn't matter. Which one do you want to do first? It's a negative. What does that negative do? It flips across the
Y, x.
x-axis. And what's our other one? It's got +2 on the inside to tell us to do. Left 2. Not right 2, but left 2. Oh boy. All right. Parent function for square root. Square root of 0? 0. Square root of 1?
1.
Square root of 2?
4.
Ooh, trick question. Square root of 4 is 2. You can't really do the square root of 2. So square root of 4 is 2. What's the next point I'm going to graph? 5? 6? 9? Okay, what's my y value if x is 9? Nice. 3. It's that little hook thing. You alright? Okay. Okay, transformations. Let's go left to right. How we see them written on the paper in ink. So let's first flip it. So that means that 0, 0 stays there. 1, 1 now becomes 1, negative 1. 4, 2 becomes 4, negative 2. And 9, 3 becomes 9, negative 3. Okay, that's my first one. Now my next one, I'm going to move all my red dots on here for your second picture, and move all those x values to the left 2. So instead of being at 0, 0, now this one just changes this time. Hopefully I counted right. All your x values move left 2, your y's stay the same. One to 10, how we doing? 4? 9, 2. What else we got? 7? Anybody else? 70? All right. Oh, ran around. Okay, 7, 8, 9. Last one's here. Number 7, we're now writing the equation. So it says the graph of the quadratic parent function. So that's y equals x squared. Shifted 3 units to the right and 2 up. We're writing an equation. I'll start you off. Y equals. Yeah, I know. Put your socks back on. That's a little long. All right, shifted 3 units to the right. So how do I say that? X minus 3 like that? Put in parentheses. I need squared? I should have squared, right? Because we're dealing with the quadratic x squared. Okay, and what I do with plus 2? I already got 2 up there. Am I done? What? Add 2. Boom. now 8 is saying, given this graph, if I want to reflect it across the y-axis, let's change that to x-axis, shall we? X-axis, translated 6 units to the right, how is that going to affect stuff? How do I do the reflection deal? Go over to the front if you need help. How do I do the reflect? And flip it over to the axis. How do I do that? Put a minus sign in front. So I'm going to start you up again. Y equals. We just said it. Put a negative sign out there in front. Oh, looks like a dot. Sorry. Absolute value. And then I move in 6 units to the right. So if I'm at positive 1, so that's really a graphic here real quick, at negative 1. If I go 6 units to the right, I'm going to do the opposite. So I'm actually going to be subtracting 6. So if I move this over 6 units, now what value is it at? 5, right? 1, 2, 3, 1, right there. So it's going to be x minus 5. And then did I move it up or down after they gave me this equation? No. So what should that number be out there? On the outside of the absolute value? Minus 4. Didn't change a thing. Stays the same. Same. Positive 1 to negative 1. On the front, we talked about how if it's a plus symbol, it's actually the opposite, so it goes to the left. It's kind of weird. It's counterintuitive. It's opposite of what we think. Good question. Any other questions? Good or bad? Alrighty, number 9. Parent function. We're listing the parent function. Look at the table right here. We could type it in the stat, edit, do all that stuff. We could do that. Or we could just kind of guess and check here. Is it going to be y equals x? Is y the same value as x for every single number?
No.
No. So y equals x is out. I don't know what a squared, quadratic x, y equals x squared. Am I squaring each one?
No. Yeah.
I'm doing the opposite, right? I'm square rooting.
Yeah.
So that's going to be my parent function, square root, which is y equals what?
Square root of x.
Square root of x. Okay, transformation. So we're looking at the table. Did my x values change at all?
No.
No. What changed?
Your y.
My y's. What does it look like I did to my y's? Moved up 3. So let's see. 0 plus 3 is 3. Plus 1 is 4. Plus 3 is 5. Oh, look, we got a pattern here.
How do you know you, why did you choose 3?
Goes from 0 to 3. 1 to 4. 2 to 5. Yeah, so we went up 3 because my y value increased by 3. My equation, am I going to mess with anything on the inside of the square root?
No.
No, I'm just going to put a plus 3 on the outside.